Good day, our dear televiewers and listeners. I am Romizelle Peniafel, a teacher from Cabanatuan City Senior High School, your teacher presenter in Earth Science for DepEd Hour Teleturuan. Today, we will be talking about how stratified rocks are formed. And at the end of the lesson, you are expected to, number 1, describe how layers of rocks are formed, and number 2, describe the different methods of determining the age of stratified rocks. But before that, let us define first what is stratification to help you better understand our lesson. Stratification is a general term for layering in sedimentary rocks. When layering of sedimentary rocks are greater than 1 centimeter thick, it is referred to as beds. And while lamination is the layering in sedimentary rocks which are less than 1 centimeter thick. So how does sediments accumulate to form layers of rocks? When sediments accumulate, either through deposition of clastic sediments or precipitation from solution, they tend to blanket or cover the surface. The surface of accumulation is generally topographically low and flat, therefore forming tabular layers. Another is if conditions on the surface do not change, and that is constant rates of weathering, erosion, and deposition, only thick, homogeneous, and undifferentiated sedimentary rocks will form. Bedding or layering in sedimentary rocks is a reflection of the changing conditions during deposition. Beds or layers of rocks are clearly defined by change in color or shape. And a change in color can reflect differences in grain size and or composition. Grain size in sedimentary rocks is commonly affected by the energy of the environment of deposition. So it's like fine grain uses low energy. And another is weathering rates are also affected by climate changes. So there you have it. We are about to have a short break. For a few reminders from the studio, please stay tuned for the continuation of the discussion on stratification of rocks. Welcome back to DepEd Hour Teleturuan. Let us continue. Which layer is the top and which is the bottom? What do you think would help us in determining the correct sequence of layers? Superposition states that in an undisturbed accumulation occurs, the bottom layers was formed before the top layer. However, rocks may be subjected to deformation, which may cause discrepancies in determining the correct sequence of layers and geological history of an area. So in this case, there are two methods that we can use to help us determine the age of the stratified rocks: the relative and absolute dating. Relative dating is when you give the age of a rock or fossil compared to another rock or fossil. For example, rock A is older than rock B, and an actual age in years is not determined. Relative dating applies the following principles: the principle of original horizontality, the law of superposition, principle of lateral continuity, principle of cross-cutting relationships, and principle of unconformity. Principle of original horizontality happens when sediments are deposited that form horizontal or flat layers. Law of superposition states that the deeper layer must be older than those closer to the surface because new rock layers are always deposited on top of existing rock layers. Principle of lateral continuity. Rock layers extend laterally and cover very broad areas, especially if they are formed at the bottom of ancient seas. So as long as there is sufficient supply of sediments, the layer will continue to extend further. The principle of cross-cutting relationships. It states that a layer or stratum must always be older than any feature that cuts or disrupts it. For example, if a layer is cut by a fault, the layer is older than the fault that cuts across it. The principle of unconformity. It states that rocks above an unconformity are younger than the rocks below. There are three different types of unconformity. The first one is the angular unconformity. Attitude of beds above and below the surface of erosion or unconformity are not the same. Next is the nonconformity. The layer below the erosional surface is either a metamorphic rock or an igneous rock, and the layer above is a sedimentary rock. And the third type is the disconformity. Sedimentary rock strata above and below the surface of erosion are parallel to each other. Then we have absolute dating. With the discovery of radioactivity in the late 1800s, scientists were able to measure the absolute or the exact age of seam rocks in years. So this allows scientists to assign the numbers to the breaks in geologic time scale and get an absolute age of a rock or fossil. In absolute dating, there are three methods used: the radiocarbon dating, potassium-argon dating, and then the uranium-lead dating. Radiocarbon dating is used to find the age of once living materials between 100 and 50,000 years old. Usually, it is used to determine the ages of human fossils and habitation sites. Potassium-argon dating is used since potassium is common in many minerals such as the feldspar, mica, and amphibolite. With its half-life, the technique is used to date rocks from 100 years to over a billion years old. Argon, a gas, has been observed to escape from molten magma. Thus, any argon that is found in an igneous crystal probably formed as a result of the decay of potassium-40. The two uranium isotopes are used for uranium-lead dating. And this is uranium-238, which decays to lead-206 with a half-life of 4.47 billion years. And uranium-235 decays to form lead-207 with a half-life of 704 million years. So what can we learn from this? Absolute dating helps us determine the age of the Earth. It also helps us determine when specific events in the history of the Earth happened, such as the extinction of the dinosaurs. While relative dating can help us estimate the time span between major earthquakes and tsunamis, storms, etc. And also, it can help us determine the order that life forms develop on Earth. So that's all for now. Once again, this is Romizelle G. Peniafel of Cabanatuan City Senior High School. See you again next time.